So this is our final lesson here in Unit 18. We've been working on polygons all along, and the big thing we're going to work on today actually doesn't have anything to do with polygons. We're going to look at some angle relationships when you have a situation where you have two parallel lines with another line that cuts across them. So this is the situation that I've described. We've got two lines here, A, B, and C, D. These two lines are parallel to each other. And we've got this third line labeled EF here, which cuts across those two parallel lines. This line EF is called a transversal. Okay. Because it transverses our two parallel lines here. And there are three relationships that you need to know between the angles formed between our two parallel lines and our transversal here. So the first relationship is what we call alternate angles. In this picture right here, the two angles indicated by these black dots here are alternate angles. Okay? And alternate angles are equal to each other. So this angle right in here and this angle right in here are the same size. We don't know what size they are on this diagram, but we know that whatever they are the same size. The way to recognize this pattern is that, let's see if we can get the highlighter going here. Maybe not. Oh, here it is. Look for a kind of a Z pattern here. So if I draw along one of my parallel lines, along like that, and I've got these two angles that I've indicated here are sort of in the corners of that Z there. That indicates that they are alternate angles and that they're going to be the same size. So let's just say look for the Z pattern. Okay. And the Z pattern, that's kind of a backwards looking Z. We could also have a Z that kind of went like this, then down like this, and then back like that. That would tell us that this angle in here, in this corner, and this angle in here, inside that corner of the Z, are equal as well. So that's another pair of alternate angles. The next one to remember are what are called corresponding angles. Corresponding angles are also equal. So in this diagram, the corresponding angles are X and X. They're labeled with the same symbol. Y and Y are also corresponding angles. Now, how do you recognize corresponding angles? Well, just like up here we had a sort of a letter pattern here, corresponding angles form, let's say, look for what we call the F pattern. Let's get the highlighter out here again. If I draw a line like this, and then like this, we've got kind of a tilted F there with those two parallel lines, part of those two parallel lines making the arms of the F. Our corresponding angles fall underneath the arms of the F. So we got Y and Y in here as corresponding angles. Now our F can be backwards, it can be upside down, it can be sort of rotated any way we want. So we could find an F pattern kind of like this. Okay, again, parts of those two parallel lines form the arms of the F. And the two lines that are sort of, in this case, on top of the arms are the same. So X and X are corresponding angles. The third relationship you need to know are what are called co-interior angles. Co-interior angles, they also form sort of a letter pattern. They form kind of a C pattern here. So let's use the highlighter again. If I go like this, 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 we've got a little letter C there. Okay? The two angles that are co-interior are inside that letter C. Okay? So let's say look for the C pattern. Okay. What do we know about co-interior angles? Well, those two angles that are inside that C pattern so C for co, interior meaning inside, they add up to 180 degrees. So A plus B equals 180 degrees. And we actually saw this yesterday when we were looking at that parallelogram, and we had those two angles that were next to each other in the parallelogram, because, you know, we can just imagine turning this thing into a parallelogram. We saw that those two angles that were next to each other had to add up to 180 degrees. So our three patterns here are Z pattern, our F pattern, and our C pattern. So usually what you need to do here is use those patterns to find the measures of unknown angles. So our first question here, we've got two parallel lines, transversal running through them. We have one angle there, 65 degrees, and two angles, unknown angles, C and D. We want to figure out what are the values of those angles, C and D. So where would you start here? Let's try looking for one of those patterns here. The Z, so kind of like this. Okay, so let's do the Z here. Okay, there's definitely a Z there. Now Z is going to give us a relationship between this angle here and this angle right here. So we know that this angle here is 65 degrees. So Michelle, what is this angle over here going to be? Yeah, this one over here is 65 degrees. Okay, how does that help us figure out what C and D are?
For C, you could do like
Okay, so it's like a straight line, so we know that C and 65 add up to 180, so C must equal 180 minus 65 degrees. So we punch this into our calculator, and we get 115. Okay. Emerson. Yeah. An F pattern like this, and then down like this, and then down like this. So this is giving us a relationship between this angle and this angle. So what does that tell us that D has to be, Emerson? It's got to be 65 degrees, because those two angles under the arms of that F have to be the same. Now, can we check our answer here? Usually we can in these kinds of questions. If we look at C and D here, we notice that the two of them together form a straight line, so they have to add up to 180 degrees. So if we look at our answer for C and our answer for D, yeah, if we add those two up, they're going to be 180 degrees. So that suggests we've done it right. So with these questions, there's usually one or two ways of doing them, and that lets you check your answer. All right, let's have a look at the next one here. Again, we got two parallel lines. They're split with a transversal. This time we have three angles that we're trying to find here, A, B, and C. Now, quite often, the letters give you a little clue as to the order you should try to figure them out. The letter that comes first in the alphabet is usually the first angle you should try to find, but not always. But let's try that in this case. How can we figure out angle A here? It's a good place to start. What do you think, Emerson? Yeah, you've got a nice little Z pattern here like this. Okay? It's a little bit, the Z is kind of sideways, but that's okay. We're always looking at those two angles that are sort of underneath those arms of the Z there. So what does that tell us about angle A there, Emerson? Yeah, because those two angles in that Z pattern have to be equal to each other. And a lot of times, you know, you give your answer there in one step. You can just sort of put in brackets after it which of those rules that you use there, the Z pattern. Okay. So now we've got 125 here. Another thing that's helpful doing these questions is once you figure out one of these angles, write the answer onto the diagram. Okay. So now we know what A is. I'm going to put 125 right there. So let's work away on, let's do angle B next. Who wants to try angle B? Oh, Emerson's going to take all the glory here. Go ahead, Emerson. Yeah. We know that 125 and B have to add up to 180, so B must equal 180 minus 125. So 180 minus 125, we punch this into our calculator, we get 55 degrees. Okay. Now, what's that property that those two angles have to add up to 180 degrees? What do we call angles that add up to 180 degrees? Supplemental angles, yeah. So we could just write in brackets here, supplemental angles, as sort of a justification for why we're doing that. Okay, now we're down to the last one here, angle C. How can we figure out what C is going to be? Oh, I should have put 55 degrees on here. Okay, there we go. How can we figure out what C is going to be? Actually, the easiest way of doing C is something that we did yesterday, but there's a couple of ways here. Go ahead, Michelle. No, go ahead, go ahead. I'm sure you don't know what it is? Okay. Anybody else got an idea for C? Chris? Yeah, so they have to be the same. Yep, they're opposite angles because they are across from each other, sort of across that vertex there. So we can say that A must equal, oh, sorry, we're doing C here. C must equal 125 degrees, and I just might say that these are opposite angles. Okay. And let's see, if we put on that this is 125, we could have done C first, because if I look at this, and this, we've got a little F pattern there, which suggests that this angle here and this angle here have to be equal, and sure enough, they're both 125 degrees. All right, let's try a couple of slightly trickier ones down here. Here we've got two parallel lines. We've got this line coming down here, which is our transversal, only it doesn't look like it. And this one over here is another transversal going up there like that, even though it doesn't sort of extend all the way across. So I could sort of imagine that going up like that, and that going like that, and this one coming down like this, and this one's still going down like this. Okay? So it looks a little bit more like our parallel lines here. And we've got three angles we want to find, D, E, and F. Okay. In this one, I think there's only one way to go. I think we have to start with angle D. Or we can start with angle F. Yeah, there's two ways of doing it. Which one do you want to start? Emerson. Yeah. And how do you know that 70, 75, and F have to add up to 180? Because they're the interior angles of a triangle. So to calculate F here, we do 180 minus 70 minus 75. And we punch this into our calculator here, and we get 35 degrees. And if we wanted to justify this, we might say that these are interior angles of a triangle. And draw a little triangle there, because triangle is a long word. I'm tired of writing it. Okay, so we've got our first angle there, F. I'm going to put on that 35 degrees right there. Okay, where do you want to go from here? Go ahead, Emerson. Yeah. We've got a Z pattern like this. We've got angles there and there. So what does that tell us about angle E, Emerson? It's got to be equal to 35 degrees. So E is 35 degrees, and here we've used the good old F pattern. And let's put that on here. Okay. And where do we want to go? Oh, Emerson's gonna finish this one off. Go ahead. Yeah, we got a Z pattern here. Oops. Backwards Z right in here with D and the 75-degree angle. So what we know is that those two angles that are in the corners of that Z there have to be the same. So we can say that D equals 75 degrees. And we used our Z pattern. Okay? And there's a way we can check our answer here. If we look at D, our 70-degree angle, and E, our 35-degree angle, those three angles together form a straight line. They are all together, they are supplementary angles. So they should add up to 180 degrees. And sure enough, if we do 75 plus 70 plus 35, we get 180. So we're good. Okay, last one of this type here. This one is even more confusing here. We've got three angles we got to find here. Where are our parallel lines? Well, our parallel lines are here and here. We got a transversal here, and we got another transversal right here. Where can we start? It says M, N, and K. I think the easiest one to start with is M. How can we get angle M here? Lexi? Yeah, so they have to be the same. So M is going to equal 40 because the 40 and the M are opposite angles. And I'm just going to write opposite in there. Okay, so now we got that 40 in there. What can we do with that? Let's see. Emerson. There's an F pattern to N. Ah, I see it now. We do this, this, and this. Okay. There's our F pattern. That tells us that these two angles underneath the arms of the F have to be the same. So N is going to be 40 degrees using that F pattern. So let's write that on here. 40 degrees. Okay. We still got K here. How can we figure out K? Let's see. Yeah. We go like this, this, and then this. We've got a Z pattern here with that 85-degree angle. So K must equal 85 degrees. And oh, I almost wrote F there, but it wasn't an F, it was a Z pattern. Okay. All right, so there we go. That's using those angle properties. Now, the one other kind of question that you need to be able to do here involves a little bit more algebra. Okay, so it's taking all of these angle relationships that we've talked about in terms of parallel lines and transversals, interior angles of triangles, exterior angles of triangles, complementary, supplementary, et cetera. And instead of giving you the values for the angles, they give you algebraic expressions here. So they've given us a triangle. What do we got? RST here. And two of the angles are given to us in terms of expressions. We've got 8x minus 3 and 4x plus 9. And we've got this third angle in here, which is 90 degrees. What we want to do first is figure out what x is, and then we want to figure out what each of these angles, angle S and angle T, are going to be. So what do we know about the interior angles of a triangle, first off? Lexi. Add up to 180 degrees. So we know that to get 180 degrees, we have to add, I'll just write angle R plus angle S plus angle T. Okay? These three angles, R, S, and T. Well, what do we have as expressions for these angles? Well, angle R is 90 degrees. Angle S is 4x plus 9. And angle T is 8x minus 3. This gives us a little equation that we need to solve for x. So let's start by collecting like terms on the right-hand side. We've got 90, 9, and negative 3. So we'll have 180 equals 90 plus 9 is 99, minus 3 is 96. And we have 4x and 8x. We add those guys up, and we get 12x. So we've collected our like terms here. What are we going to do next to solve this equation for x? Think way back to Unit 5, 6 here. I want to get x all by itself here. I need to, Emerson, there's a step before division. Before I divide, I'm going to subtract 96 from both sides, right? We always do this subtraction or addition step before we do that division. So right here, these guys are going to cancel. I'm going to have 180 minus 96 is 84. Then we are going to divide. And we get x equals 84 divided by 12. X equals 7. All right. Are we done? Almost. We still need to figure out what these angles are. So one of our angles is 8x minus 3. So t equals 8x minus 3. We've got a value for x here, so let's just sub it in. 8 times 7 minus 3. 8 times 7 is 56. 56 minus 3 is 53. So angle T is 53 degrees. And then we need to do the same thing for angle S. Angle S is 4x plus 9, so 4 times 7 minus 9. We punch this into our calculator. 4 times 7 is 28. 28 plus 9 is 37. Okay. Now, how can we check our answer to make sure that we've done all this correctly? That's right. Yeah, check and see if S plus T plus the 90 that we have at the beginning adds to 180. So we just punch this into our calculator and see that we got it right. Go ahead, Nazrat. You can check it. Emerson's already nodding his head. He says, yeah, you've done it correctly. Okay, great. So we got 2 more questions here. I think we'll just do one of them because you guys get the idea here. We'll do this one here involving the parallel lines. So we got 2 parallel lines cut with a transversal. We've got angles x, y, and m and n there. And we want to figure out what x is first, and then figure out what all the unknown angles are. So x, y, and m and n. So for this one, if we want to solve for x first, let's find all the places where we have x's. So we've got 2x minus 55 here, and we've got an x down there. So we want to kind of zoom in on those 2 angles right there. What do we know about those 2 angles? How are they related to each other? Man, they're the same. How do you know that they're the same? Not opposite, but the F pattern, sure, same F pattern. Okay. The official term is corresponding, but F pattern works just as well. Okay. So if we know that this and this are the same, that gives us an equation. 2x minus 55 must be equal to that other angle, x. And here's our equation that we have to solve. How are we going to solve this equation? We got x's on either side here. This is never going to work, right? We want to move the x's all to one side. Okay? So I'm going to move this 2x over to this side by subtracting 2x here. Do the same thing on the other side. Subtract 2x. 2x minus 2x cancels out. X minus 2x is negative x. So So I've got negative x equals 55. What must x equal here? If negative x is negative 55, x must be just 55. Am I done? No, because I want to go back and I want to figure out all these angles. Well, x was one of my angles right here. So I got x is 55 degrees. What is, oh, let's see, what do I need to find here? The angles that I need to find are y, m, and n. Okay? Because those are the three sort of unknowns that I have here. Okay? So once I know that this angle right here is 55, what can I do about these other angles, m and n? Let's start with m. How can I figure out what m is going to be there? Nazir? Yeah. They have to add up to 180, so I can do 180 minus 55 and work out what that is. That's going to be 125. Okay, so 125. What about angle n now? Up here. Emerson. With that, with the 125 that I just did. It's an upside down F here. So I know that n is also going to be 125 degrees by that F pattern. And what about our last little angle in here, angle y? Once I know that this is 125, what does angle y have to be? Michette? 125, how do you know that? Because it's opposite to that other 125. Perfect. Okay? So that's the general idea. Look for the relationship between the angles which have the variable you're trying to find, in this case x. Set up your equation using that relationship, solve for x, and then go back and try to find your angles if it asks you to. And we are done.